Well, hello everyone and welcome to Learn with GKV. Did you know that you only need 10th standard mathematics to build an AI just like ChatGPT? And in this video, my target is to give you the fundamental building blocks, the concept of how artificial intelligence works, how do you design an AI model in a computer without going into any programming or coding. Okay, so without further ado, let's get started. I'm pumped up. I hope you are excited as well. So this video is all about understanding the concept. So here's an example. What we want to give these features. So our studied IQ of a person and the name of a person. And then we also want to understand if person 1 has studied 5 hours, their IQ is, let's say, 155 and their name is Tom, how much do you think they can score in an exam? And similarly, it will go for person 2, person 3, and of course for person 4. So let's see how we can build this. By the way, off topic, quick FYI, Albert Einstein had an IQ of 160. So person 1 is pretty smart. So what I would imagine from this AI is a person with IQ 155 who have studied 5 hours should ideally score better than person 2 who has an IQ of 130 and has studied 7 hours. And of course, their name should not have any influence on how much they can score in an exam. Okay, so let's see if we want to build something like this in an AI, how can we do that? So here's the hypothetical equation that your AI should be able to, let's say, design for this very simple use case. So person 1 should be able to score some marks, so 5 hours multiplied by 17, 155 is the IQ multiplied by 3, and then their name multiplied by 0. So these are the calculated weight of an artificial neural network. So 17, 3, and 0. But the question is, how? How does AI learn to give a weight to a given problem? And the how part is answered by giving computers a brain just like humans. So our aim is to build an artificial neural network in a computer, just like the way we have in human brains. So if you see on the image on the right side, there's a human brain, and within the human brain, we have something called billions and billions of neurons. So if somehow we can build a network of neurons within a computer, we have ideally created a human brain in the computer. And the second step would basically be to train it, give it some data, and let it learn from the data. So this is what we would ideally like to do when we are building an artificial neural network. So step 1 is to design a neuron. Step 2 would be design a network of neurons. And as I said, now step 3 would be to train that network of neuron on a specific set of data to perform a specific task. So here's an image of a neuron taken from the internet. You should ignore all of these names, for example, dendrite, cell body, blah, blah, blah. We are not looking into the biology of it. We're looking into the mechanics of neurons. Our task is to mimic how neurons work, and to do that we have divided neurons into 3 parts. Number 1 is a head of neuron. This is where we do all sort of mathematical calculations. Then we have a body of the neuron, and this is where we apply something called activation function. And we'll talk about what activation function means, what calculation means in a moment. And the last is the tail of the neuron. This tail is responsible for communicating data or information from one neuron to another neuron. This is how a neuron works in human brain, and this is what we would like to build in our computer as well. So that's how one neuron will be connected to another, and we will build a specific network of neurons so that it could perform a specific task that we want it to do. This is so exciting. So, let's design a human neuron in a computer, and we'll do it in 3 steps. In the head of a neuron, we will take some inputs. So for example, how many hours did the person study, what is their IQ, and what is their name. It doesn't matter if data is relevant or not. So this is something what we will do. We'll take some inputs and we will use some random weights, and we'll just take a summation of it. So input 1 multiplied by weight 1 plus input 2 multiplied by weight 2 plus input 3 multiplied by weight 3. We'll take a sum of it and we'll call it Z. This is what we want to do in the head. As you can see, it's not super complex. It's actually extremely simple. All you need to know is how to multiply and add two numbers. Okay, so that's step one. We have designed the head of a neuron. And some of you must be thinking, this is something which is not too complex to build in a computer, right? It's basically designing a data structure. For example, the way you have stack data structure, the way you have a queue data structure, the way you have tree data structure. Similarly, we have a neuron data structure, if you want to call it that way. The second part of the neuron is the body of it, where I said we will use some activation function. So for example, what an activation function means is if value of this summation x1 plus w1, x1 into w1 plus x2 into w2, if the summation, the z value, is greater than, let's say, 70%, we'll call it 1. If it is less than 70%, we'll call it 0. And finally, the tail of the neuron is the output that we want to give out from this neuron, which basically means that we calculated the sum, we applied the activation function, if it is more than 70% or not. If it is more than 70%, we give an output of 1, else 0. And this is how a deep neural network might look like. And every circle is basically one neuron, and then you connect one neuron with another in a very specific manner so that you can get a specific neural network. Okay? Perfect. Now let's take all of this together and see one specific example of how a neural network or artificial neural network will work. So here's the data set. So we are saying that I have a house 1, its price is 100 because it has only one room and one toilet. There's house number 2, which has 2 rooms, 2 toilets, and the price is 300. Similarly, we have different data set, and what we want to do is we want to give our artificial intelligence 2 inputs, one for rooms and one for toilets. And at the end, we want only one output where it predicts the price of that house. Okay. In between, there are hidden neural networks which will do its calculation based on the weights and biases. We're going to look into that just now. So once we design a neural network, we will initialize it with random weights. Let's say for neuron 1, we give weight 1 and weight 2. So these are all random weights. Similarly, we will give weights to this neuron as well, W4, W3, and W6 and W5. Then we will give inputs to those neurons, so X1 and X2. Based on these X1 and X2 and weights, these middle neurons will calculate Z1 and Z2. And then finally, we will calculate our output, which will be Z1 multiplied by weight W5 and Z2 multiplied by weight W6. And then there's a bias B3, and you also see B1 and B2 here. These are just some random, let's say, bias or number that we provide to each neuron. Okay. So once this network calculates all the value, which is Y, so that would be our output that this neural network provides. And all of this is called forward propagation. What this means is we give an input, the network will calculate the weights and give an output. So this is called forward propagation. Once we do this, once we do the forward propagation, once we take the data, calculate its weight, present an output, we will compare this output price with the expected price. So for example, let's say it gives an output of 300, but we were expecting the value should be 100. Therefore, the error is 300 minus 100, which is 200. Then we use that error and do a backpropagation on the network. Using that error, we tell the network, hey, you being a bad AI, you need to adjust your weights, so W1, W3, W4, W5, W6, so that when we do a forward propagation, the error should be as small as possible. So your job is to adjust all the weights so that when you give an output, it should be as close as to the expected value. Seems like the calculation of error is rather important. But the question is, how do we calculate error? Well, this is where the 10th standard mathematics comes in. Let's understand that. So this is how it works. Any network that you design will internally or conceptually will have some sort of equation to it. For example, what you see on the screen, we have a graph which has an equation of x squared plus 3. When I put a value of x as 1, I get 1 square plus 3, which is 1 plus 3, which is 4. So I get a value of 4 somewhere here. Now, as I mentioned that we're going to start with random weights, which means that your AI would basically be starting from this point. Let's do it here because for some reason my pen is not working. So let's say internally your artificial intelligence has designed an equation for your problem which looks something like this. Now, since we initialize everything with random weights, let's say your initial point was here, and based on this it was giving you a value of 200, but you were actually expecting 100, therefore there's an error of 100. What we do is, and this is where the 10th standard mathematics comes in, we differentiate this graph at this point. So if the equation is x squared plus 3, if this is y, then dy by dx would be 2x plus 0, which is basically 2x. And then we put the value of x and we figure out, okay, at this point the slope is positive, therefore I need to move down because this is where the minimum is. So this is where the minimum is, this is where we want to go. And that's it, that's all the mathematics that you need to know. And the best thing is when you use programming languages, for example, TensorFlow or PyTorch, all of these calculations of getting the differential, getting all these values are already being coded for you. All you need to do is call a function and that's it. How amazing is that? So let's see that step by step. So we start with an initial weight somewhere here, and we say z, which is our output, is x1 multiplied by w1, w2 and w3. Then we say start with random values. So let's say weight was 120, 11 and 20. Normally the weights are actually in floating points, but for the sake of example, I'm just taking integer so that it's easier for us to understand. Then we find the gradient and we do an incremental step to go down and find the minimum value, which is here. Then we do it again. So you see from 120 it becomes 100, from 100 it becomes 10, and then finally it goes to 7 and 3, and technically that's the weights that we were looking for. So in the previous example, I talked about incremental step. What is that? Well, the way we calculate the new weights is by this formula. As you can see, it's extremely simple. We are saying the new weight would be the old weight minus n times whatever the derivative is. So whatever the derivative we found here, we'll put it here, and then we will multiply that with n, and then we will subtract all this value from the old weights, we will get a new weight. Now the reason we want to do it in an incremental step is because if n is very big, let's say 100, and let's say you start from here, what you will end up doing is at this point you will say, okay, I have to go down, but since n is super huge, you will basically jump around the curve instead of finding the minima if you do it in an incremental way. The opposite of that is if you take a really small n, then you will do a lot of iterations. You will try to go to the zero or the minima, but you will never reach there because your steps are so tiny. And this is where all the things that you hear from all the buzzwords that we need to train the AI, we have to test the AI. This is all we are doing basically. We are trying to find the local minima or the global minima with testing the incremental rates, because everything else is basically constant in your artificial neural network. All you can change is learning rate and initialize the weights, and keep giving it data so that it can learn to go to the minimum. That's it. What I want to show you is a very interesting thing, and this is where it blows my mind. So let's go to Google and look at this. So if I go to Google and search for gradient descent, go to images. This is the image that I showed, but this is a very, very simplified example. What I'm saying is the internal representation of the problem that you're trying to solve using AI has a graph of 2 dimensions. That's it. And you and I, as a human, we can visualize 2 dimensions, right? I know that it has only 2 dimensions, X and Y. What you see here is a graph of 3-dimensional problem statement. So it has an X, it has a Y, and it also has a Z axis. And this is a 2-dimensional representation of 3 dimensions. The magic of mathematics is that once you know that taking a derivative and updating the weights works in 1 dimension, 2 dimension, and 3 dimensions, it will also work when you do it in 1,000 and sometimes 10,000 dimensions. These are dimensions so big that our human brain cannot comprehend, but we know the math works. Okay, beautiful. So with all that understanding, let's see how our simple neural network will work to predict the house prices. So we start with random weights, 0.45, 0.56, 0.5, 0.25, 0.56, 0.64. So this is how we initialize our network. Then we provide the inputs. Input is room equals to 1, toilet equals to 1. Our task is to figure out what should be the price of the house. So as a step 1, what we will do, we will calculate Z1, then we will calculate Z2, and eventually we will calculate Y, which is our output. Okay, this is obviously the forward propagation. We have already seen this. So let's do some math. So Z1 would be X1W1, X2W2 plus B1, some random bias. So putting these values, we get Z1 as 200. Similarly, this should be Z2. So let's fix it. Similarly, we will calculate Z2. So X1 into W2 is 2 into W3 plus some bias. Again, I'm taking some random bias. And we get a Z2. And then we apply an activation function of both of them. And then we calculate Y based on Z1 and Z2. Let's say the value is 311. And this is how we will calculate the error. We will say, okay, you were expecting a value of 100. You have calculated 311. So the error is 211. Why don't you go back to the network, update the weights, and then we try again. And we do this back and forth, back and forth, back and forth, thousands of times until we have adjusted the weights such that our error is as small as possible. And that's it. That's all there is to conceptually understand what is happening within one neuron. Actually, I lied. There's one more thing that I did not discuss, so let's look into that as well. Remember this slide where I said, in addition, while we are calculating the sum, we also use an activation function. If it's more than 70%, make it 1. If it's less than 70%, make it 0. Let's see how that works. So if we zoom in to one of the neurons, you will see that we calculate the Z like this. And once we calculate the output of that neuron, we also apply an activation function to it. So it basically looks something like this. So we calculated 200, and then we apply a very famous function called ReLU to get the value of Z1. If you're really interested, what you can do is you can go here and say, ChatGPT, give me a Python code to implement ReLU activation function If I copy this, go to Google Colab, open a new notebook, paste it here, and then if I run this, you will see that what this function does is saying take a maximum of 0 or x. So anything which is greater than equals to 0 will get its own value, otherwise it will be trimmed down to 0. And that's basically what this value function does. It is here. Again, you don't have to implement any of these. All of this is already done in, for example, PyTorch or TensorFlow, whichever programming language you're going to eventually use to design your machine learning or artificial intelligence models. Okay, coming back to our discussion. So something like this. Once you apply the activation function, it will become this. So far what we have learned in a given neural network, we will need inputs, we would need weights, we took a sum product of those, and then we apply an activation function on it. This is our forward pass. Eventually we also calculate an error. What I showed you here, that a minus b, doing an error like this, doing an a minus b, is kind of misleading because this is not how you would calculate an error. Normally you would calculate an error using a loss function. A loss function could be, for example, in our use case, could be mean square error, which is basically implemented like this. Again, you don't have to go into the math of it. All you need to know is what kind of loss do I need to use so that my network is able to minimize it and my output is as close as it should be to the real value. For example, in our case, we want to calculate mean square error, which basically means something like this. So if I open an Excel, so while it's opening, let's have some water. Okay, let me zoom in. Rooms 1, price per room. So if you remember, the AI will start with random weights. So let's say it just thought that, okay, randomly price per room would be 200 and fixed cost should be minus something like this. Okay, so the house price is this. The error would be this minus that. If you take a sum of it, this is my total error. When it does the first forward propagation, it will get an error of something like 25,000. We will send it back to the network. We'll say, hey, please adjust your weight. So let's say it goes to 80. This goes to minus 200. We'll see, okay, we are getting close to the zero error. The error should be 0, so as close to 0 as possible. Then it will again go back, update the weights. So let's say this becomes 90, this becomes 90 again. So we see, the error went up, we want to reduce it. Let's make it 50, let's make this 100. We're getting down, let's make it 20. Getting closer, let's make it 2. Again, went too far, so let's make it 11. Now it looks like we're getting close, and eventually the network hopefully will converge to this value, and the total error of the model will become 0. That's a simpler way of saying it. And then you can use mean squared error. The formula is this, so you implement that. And as I mentioned multiple times before, all the maths for all the loss function, all the activation function is already been coded in PyTorch and TensorFlow. You don't have to worry about it. Then there are a lot of other kind of errors that you can use to calculate based on your specific need. For example, MAE loss, Hubble loss, binary cross entropy, softmax, and many more. we have covered a lot, so let's do a quick recap super quickly. Our target was to understand how does machine learn without using any programming. We wanted to understand the conceptual building blocks of it. And to do that, what we did is we looked into the human brain, and we wanted to find the fundamental building blocks in human brain. How do humans learn? We identified that human learns with the help of neurons, and that is what we wanted to build in a computer. How do we do that? We designed a neuron, we designed a network of neurons, and then we trained that network of neurons on a specific set of data to get a specific result by using forward propagation and backward propagation, using random weights, activation function, and we used a loss function. Alright, we are coming to the end of this video. We have learned how AI learns and grows, but do you know how your favorite channel Learn with GKV grows? But it does it in 3 steps. I'm sure you know this, but I just want to repeat it. So number 1 is you have to like the video. Share this video with 3 of your friends because this video creates value. And lastly, comment on the video about your thoughts, about your doubts, any topics you want me to cover, any challenges that you face. And all of this is a zero-cost effort that you can do today to help us grow the channel. Alright, with this, GKV signing off. See you in the next video.